Hello, listeners, and welcome to the podcast series of the BAJ Academy of Jewellery. I'm Sophie Boons, and today I have invited another guest to join me in a jewellery discussion. There are numerous techniques to make jewellery, and to master them, you need practice. To innovate with them, you need an open mind and curiosity, and to ensure they don't get lost over time, we need to document their use and share the knowledge. In an age where time is money and digital technologies are enabling us to work even faster, it is more than ever important skills and techniques are mastered and then shared. So how is it done? To discuss this and his practice, I have invited jewelry master and researcher Jim Binnion. Welcome, Jim.
Thank you very much. Glad to be here.
Jim, can you tell us a little bit about yourself to start and what you do?
Let's see. I grew up in a family of people that made things, not necessarily as a professional practice, but my mother is an artist, photographer, and my grandmother was a furniture maker and doll maker and weaver, and just about anything she saw, she had to try it and do something with it. And then my father was very handy with carpentry and that kind of thing. But, you know, my father was also a fighter pilot in the Air Force, and then left the Air Force and got involved in banking and finance. And I think he frankly would have been a lot happier if he'd stayed making carpentry stuff. But anyhow, so I grew up around a lot of people who were constantly making things. And so it just seemed to be a normal way of life to me. When I was probably, second grade time period was the time of the first United States manned space flight launches, the Mercury program. And so I got very interested in that, you know, in part because that was very exciting and on the news and that kind of thing. And then, you know, with my father having been a fighter pilot, you know, aviation was kind of, a part of my household. So I got very interested in science fiction and science, and, you know, I was going to be an astronaut, you know, like probably every other young boy my age. You know, that was the big thing, because they were, you know, the national heroes at the time. You know, as I went through school, I ended up being one of those, well, if I'd been born, you know, 20 years later, I probably would have been diagnosed as being ADD or ADHD. School and I didn't get along real well. I was continuously bored and acting out and wasn't the best of students. But when I got to high school, one of my friends showed me a piece of wax that he had carved and built up, and then showed me the ring that he was going to make out of it, that he was going to give his girlfriend. And, you know, at 14, girls, jewelry, girls like jewelry, maybe I should go learn how to make jewelry. So I kind of started in taking the crafts class because of seeing that ring. And the school I was in had a fairly decent sized crafts class. There were a couple of teachers, and we were able to do a lot of different things. So I learned the basics of lost wax casting. I learned the basics of fabrication in that class. And so that was starting at 14. And so at that point, that kind of displaced my idea about becoming an astronaut or some kind of scientist or engineer or something like that involved with the space program. And I was like, for cultural context, I was living in California, San Francisco Bay Area. This was the early 1970s. So, you know, everybody was running off to the hills to go, join a commune and live off the land. And, you know, we were all going to make stuff, and, you know, that's how we were all going to move forward. So, my idea is I was going to make jewelry for a living in this mythical commune that I was going to live in when I grew up. So anyhow, that's how I got started in making jewelry. I got distracted for a while. I moved to Colorado when I was 19, and I was working for a sculptor. We were doing fiberglass and other types of sculpture work for him, building models of stuff. We would mold his sculptures and then cast them and plaster and fiberglass and things like that. And one of my friends worked for a electronics company in Colorado, and he showed me this thing called a microprocessor that was going to revolutionize the world. We were going to be able to do things like make robots and do all of this really cool stuff. So it's like Zoom, hey, here I go. I'm off to the high-tech stuff again. I'm going to go make robots and learn electronics. And the only problem was I didn't have an academic background and didn't have any money to go to school. So let's see, this was like 1976 or so. And in 1977, I ended up joining the Navy because the Navy was going to pay me to learn electronics and send me to schools, the technical schools in the Navy. And so I spent the next 9 years as a electronics technician on a nuclear submarine, and didn't do much jewelry during that time. Kind of hard to have jewelry making tools on board the submarine. Didn't really fit in with that whole thing. But towards the end of that time period that I was making holes in the water and riding around on a nuclear submarine, I'd kind of had enough of that whole thing. The military and everything. I had this bad question of asking why rather than yes, sir. So I decided it really wasn't a place for me to spend the rest of my life, and was planning on getting out. And I saw an article in a newspaper that talked about a local school. I was based in Northern California in the San Francisco Bay Area. And there was a small submarine facility in the northern part of the San Francisco Bay. And there was an article about this guy named Alan Revere, who was running a jewelry making academy in San Francisco. And I was like, oh, I really enjoyed doing that. So I started taking classes at Alan's academy. He was teaching in nights and weekends at that point. So I got back into doing casting and a few other things. I started doing a lot of reading and looking at stuff and getting back into my jewelry making. So I set up a small studio in a spare bedroom and taking classes and making stuff in my apartment. And some point there, I had seen some images of Mokume when I was younger. And there was a book that had just been published by Opu Unthrecht that was Jewelry Concepts and Technology, the big, thick encyclopedic book, right?
The Bible.
And there was a section on Mokume in there. And I was hauling this book out to sea with me when we were going to sea on the submarine and reading it. I read it from cover to cover several times. And so I read about the Mokume, and it's like, I want to do that. So I started trying to research everything I could find in writing about it, because this is probably 1983. There was nowhere that I was aware of in the United States that you could learn how to do it. There were really, at that point, the number of people making Mokume in the United States could probably be counted on two hands. There was a couple of schools in the upper Midwest, University of Michigan at Ann Arbor, and the Southern Illinois University at Carbondale, that had done some experiments with Mokume, and they had written some papers about it. And Hiroko Pijanowski was the one who really brought Mokume from Japan to the United States. And she was one of the professors at University of Michigan. And so I read their papers. I started trying to experiment in my own studio on doing it, and didn't have a whole lot of luck. And then, well, part of the problem was they were all working in blacksmiths type coal or charcoal forges. And at that time I was living in Vallejo, California, in a mobile home park. So, really tiny little backyard with very close neighbors. And I didn't think that they were going to appreciate me being out in my little tiny backyard with a coal forge, making a bunch of smoke and and so forth. So I was trying to do it with an electric kiln. And I finally hit upon a way to make it work in the electric kiln. And so that was 1983 that I finally was somewhat successful with that. And I've been doing it ever since. So I got out of the Navy. I ended up at that time, my ex-wife was going to UC Berkeley studying electrical engineering, and one of us needed to go work somewhere. So my idea of going back to school for jewelry was not going to happen at that point. So because I had an electronics background, I ended up getting a job at a research and development company in the Silicon Valley. So the company I worked for had been a part of Stanford University and had separated off in the 70s. And they basically were a contract research and development company that worked across an incredibly wide range of different types of research. And I got a job there working on a bunch of different electronics research programs. And that company was the third node on the original ARPANET, the beginnings of the internet. So when I went to work there in 1985, and I was becoming, when I was getting my employee check-in, and they said, here's your email address. And I'm like, what's an email address? Very soon became involved in computer networks and that kind of thing. So when this strange new thing called the World Wide Web came around, we were pretty heavily involved in using and doing some of the research. In fact, back at that point, if you wanted an internet address or a domain name, the company I worked for actually had the contract to assign domain names and internet addresses. So, we were pretty involved in it at that point. But it was still like it was colleges and the military were about the only people using it at that point in time, and researchers, So I was involved with it at work, but didn't really think about it in context of my hobby slant, whatever jewelry studio that I was still operating at home. And I was involved in an early email list that was called Art Metal. And there was a bunch of different disciplines of metalwork artists that were communicating via email on this mailing list. And at that point in time, everybody was using modems, telephone modems, to connect to the internet. So if you were to do something like send a picture of what you were making, people would be screaming at you because you just tied up their modem for 15 minutes trying to download this stupid picture that you were sending them. So we didn't send a lot of pictures back and forth on the mailing list. But this thing called the web was starting to percolate out. And Adobe came out with a program that allowed people who were not programmers to actually put up websites. And we were talking about it on the mailing list as a way to allow us to show each other what we were working on. So I applied for and got the domain name of mokumegane.com because there are no metal artists working on the web at this point in time. It's a bunch of students, college students who are studying engineering and computer programming. And, at that time, gosh, you could have gotten anything, as a domain name because nobody was doing it. So my first website went up the same year that this crazy guy in Seattle decided he wanted to start selling books on the internet. We were actually aware of it at work, and we thought it was hilarious because who in the hell is going to buy a book over the internet? This is stupid. You just walk down the street, you go to the bookstore, you buy a book, right? No. So while he became a billionaire, what happened to me is I started getting, even though my website was not set up to sell anything, it was just really a place to share pictures of my work with the other people who were on Art Metal. I started getting emails from people I did not know saying, how much is that? So I went from I had this day job where I was working as an electrical engineer in the Silicon Valley, and I would go home at night and in weekends and make jewelry. And at one point I realized I'm making as much money in nights and weekends making jewelry and selling it over the internet as I am driving 20 miles each way to my business down in the Silicon Valley. And one of these has got to go away. So I started commuting downstairs rather than across the Bay Area. And so that started my online presence, of selling things. And so from that point till now, that was, I think, late 98, 99 is when I stopped working in the electronics business and have been making jewelry ever since. So I got my interest in research working in R&D labs, but I also had the jewelry thing. So you had kind of wondered where those came from. So that's a long way around of telling you where they came from.
No, that's super interesting because it is relatively rare to find a jeweler who is one perhaps aware of all of the research practices and is willing to spend and dedicate the time to put everything detailed enough in a paper so that others can read it and understand it as well. So it's really interesting to hear that you've had an introduction to that world through another job, actually.
Yep.
You are now, of course, considered an expert on the Mokume Gane technique. Could you tell anyone listening who might not know what the technique is, what the technique entails, and why this technique has captured your imagination for all this time?
So Mokume Gane translates into English literally as wood, eye, metal. And a better, usable translation is like wood grain metal. It was originally developed by a fellow who was not a swordsmith per se, but what he did is he made what they call sword furniture, the various bits and pieces that go on the sword. So he didn't make the blade, but he made the various metal pieces that the sword guard, the various little bits and pieces that go on a samurai sword, both the scabbard and the handle. So his name was Denbei Shoami, and he lived in the 1600s. And he basically figured out how to laminate different non-ferrous metals together in a way that kind of mimicked how the swords were forge welded together. But he was doing it with copper alloys and some gold, some silver. There's nothing written about it from that time period. This was all hush hush trade secret kind of thing. But there are a few pieces that are attributed to him that still exist. So he figured out his first pieces, as far as we can tell, were a lamination of copper and a Japanese precious bronze called shakudo, which is copper with 4%, roughly 4% gold mixed into it. There's a wide variety of variations in that, but around 4% gold and copper mixed together. And they would use a patina process that would cause the shakudo to turn a black that sometimes has some blue or purple highlights, but basically it turns black. The copper goes to kind of a nice brick red. And so you've got a really beautiful red and black color contrast going on between the copper and the shakudo. So he laminated sheets of copper and shakudo together using heat and pressure, and then carved it in relief to mimic a type of Chinese lacquerware that was very popular in Japan at that time, where they would overlay different colored lacquers and then carve it in relief to almost like a topographic map. The deeper you carve, you start showing various rings and whorls and so forth of the underlying exposed layers. He called it guri bori, and the guri was one of the names for the Chinese lacquerware that was carved in relief like that. That's where he started out, was doing just layering the sheets of metal together, fusing them without solder, and then carving them and then patinaing them to make the various bits and pieces that go on the samurai sword. At some point, he transitioned further on and started forging those pieces out after carving and created patterns that were more reminiscent of wood or water flowing. We don't really know if he called it Mokume Gane. That, as far as I can tell at this point, may be something that occurred in the 19th century. I think the best I can put together at this point is that Mokume Gane would have referred to a pattern and not the process. And there are several different names that are associated with the laminated materials that didn't end up becoming attached to it as a process name that referred to, like in English, cloud metal. But basically, it was practiced by only a few people, and they were involved mostly in decorating the samurai swords. Then in the mid 1800s, there was a pretty dramatic change in Japanese society that in effect outlawed the wearing of samurai swords. And so all the people who'd been involved in making samurai swords for a living were out of work. So there was a lot of attempts to try and transition those techniques into other decorative metal arts. And there's some absolutely stunning metalwork that was done during that time period. It's just amazing. At that same point in time, Japan was opening up to the West more than it had been for several hundred years. There was some people from England, and actually probably the first written description of Mokume Gane in English is by an American in the mid 1800s. And somewhere I've got the actual quote. I've used it in several papers, but basically he's talking about it being soldered together, and this created a lot of confusion that a lot of Western artists tried for many years to solder mokume together because this guy had said soldered, and it's only later that we really learned that there was no solder involved. But there was also some pieces brought into England. There were several scholarly works written about it. So some of the first Western work was actually done in England, and also here in the United States at Tiffany and Company. And in the late 1800s, in a exhibit in Paris, one of the same time period as the whole Art Nouveau thing was going on, international exhibition in Paris, Tiffany exhibited a whole set of silverware that was done using Mokume Gane along with a lot of other Japanese techniques. The interesting thing was they actually did solder it. If you ever get a chance to look at some of this stuff, I actually have a spoon from that time period that was made in Mokume, and you can actually see they did solder the stuff together. So anyway, there was a fair amount of interest at that time period in the West in it, but then, as time went on, Art Deco came around, several world wars, a lot of other stuff happened, and Mokume just damn near disappeared. I think probably by the early 1970s, there might have been 5 or 6 people in Japan who were still doing it. And so it came near to being totally lost. Pijanowski's, Eugene and Hiroko Pijanowski came across it in Japan. They tracked down a fellow named Norio Tomogawa who taught them how to make it, and they brought it to the United States. That's how it really got back into being used in jewelry making and in metalworking in general, was that particular path. So I saw some pictures of it when I was 16. Again, as I said earlier, I learned how to start making it or making my version of it when I was in my 20s. There are certainly more people in the West making mokume right now than ever were in Japan. It was always a very small thing. And what I see that is kind of interesting is I see a resurgence of it in Japan. There are younger people making it now, doing beautiful work in it. So I think that's really great. There's some amazing stuff being done there right now.
Yeah, that's an incredible story. So could you expand a little bit, Jim, on what attracted you in particular to the technique? So why, because you've obviously spent a lot of time also modernizing the technique and in doing it in your own way. What attracted you to it? Was it a problem that you wanted to solve, or?
Two things. One, I've always been attracted to the aesthetic of Japanese artwork. That time period of the 1800s, 1800s in Japan produced some of the most amazing craft work ever made by any humans, period. There's no question in my mind that the Japanese metalsmiths of the 1800s, I don't think anybody's managed to surpass them in quality and beauty of their craft. I got really interested in Art Nouveau during high school time period. Art Nouveau drew heavily on Japanese images and, really was driven by the importing of Japanese artworks into Europe during the late 1800s. That's where they drew a tremendous amount of the inspiration for the Art Nouveau movement. So knowing about those things kind of brought my interest in that area. What attracted me about Mokume is it was so damn hard to do. The papers I was reading by the students of the Pichanowskis and at Southern Illinois, they had all kinds of problems trying to learn how to do it. And it was, I won't say that it was considered impossible, but it was considered to be ridiculously difficult to try and do it in an electric kiln. So difficult. Okay, great. That's me. I'll sign up. Let me try and do that. It was a technical challenge. It was an aesthetic interest. So I started trying to, go through a whole bunch of different attempts at how do you do this in an electric kiln? How do you get these metals to stick together reliably in the electric kiln? It's very different from the way that the Japanese traditionally did it because you're not able to watch it while it's going on. So you've got to rely totally on having a controlled temperature and a controlled environment in the kiln to get it to successfully bond. Whereas the master Japanese craftsmen would be watching the stack and they would be, manipulating it, touching it, doing things with it while they're firing it that allowed them to figure out what was going on with it. And I was working blind. What I ended up figuring out to do was basically enclose the materials inside of a box, a stainless steel box that was filled with charcoal and create the right kind of atmosphere while controlling the temperature of the metal in the electric kiln, and started to become successful in sticking it together. So when I first was doing this, I mean, there were so few people doing it. I had to explain to almost everybody what it was. A friend of mine invited me to teach a casting class at what was then California College of Arts and Crafts. And we had a couple of students in the department who were, they weren't in my classes, but I ended up talking to them and they were from Japan. And I was telling them I was working in Mokume Gane and they're like, what is that? So it's not well known in Japan. It wasn't well known anywhere. So, it's kind of nice. I'm doing something that's very unique and there are not many people doing it and all of that. So that there was that attraction. The colors that you can get with working with the copper alloys, laminating them against gold and silver and the patinas, you can get just really amazing color contrasts. Unfortunately, it's a hell of a lot of work. And one of the difficulties I ran into early on was I'd make all these earrings and neck pieces and pendants and things like that. And they're going, why would I want to buy that? That's awfully expensive because it's just copper. I ended up migrating into doing wedding rings because A, I learned how to laminate the different gold alloys together, and B, people were willing to pay a hell of a lot more for a wedding ring than they were for an earring. So in part, economics drove me into the wedding ring business. The technical challenge definitely interested me, and it took quite a while to really figure out exactly what was going on, and I learned a hell of a lot along the way about metallurgy and how metals work down on the molecular and atomic and crystal level and all of that.
Yeah, absolutely. This was going to be my next question in a way, because Mokume Gane is deceivingly more complicated than it might look to a beginner. And, you know, for one, due to the fact that you're, of course, combining materials with different molecular structures, and even though they might be metals, they are still different materials. And it requires, like you say, a really intense and good knowledge of metallurgy. I wanted to ask you if anyone is interested in learning Mokume Gane, or actually, you know, any technique. Do you think it's really important to get to grips with, you know, metallurgy and also read perhaps materials from other disciplines like physics and chemistry, etc.? And was that something you have really had to do in order to get to the stage where you are today?
So I had to teach myself a lot of those things, or, you know, find people I could ask about it, because, you know, there was no information on it. You didn't know why did it work this time and why didn't it work that time? Why, you know, what's too hot, what's too cold? All of these things that you need to know to make something. There was no body of knowledge available where I could go and read about it. So I had to learn a lot about metallurgy to be able to do what I'm doing now. Do you need to know that kind of thing? No, but the knowledge will allow you to look at what you're doing and understand why something works or why it doesn't work, or make a good guess about, well, if I do this, this should allow me to do that. I think that most people who are craft or art oriented often struggle with the more science and engineering oriented disciplines. You know, I think for most of us, there's a difference in how our brains work on one way and versus the other. But I think it is important to try and understand at least some of the basics of metallurgy to be a successful jewelry artist. If you're actually going to be somebody who is making things, you know, working with the metal, you need to understand how the metal works, because it'll save you a hell of a lot of time and frustration in the long run if you kind of have a basic understanding of this. And there are a couple of really good books that are written more for the jewelry artist or technician, craftsman, whatever, than for an engineer. I think if you study those, or, you know, at least have them on your shelf and are able to go reference them when you need to, that they're a really good way to get some of that information in your head and try and help you understand what's going on. Because it's not just Mokume, it's soldering, it's annealing, it's all of the things that we have to do with metal. You know, there's a reason why we do it. And unfortunately, there's a tremendous amount of knowledge that is not so great that gets handed down from one craftsperson to another, where they try and come up with a reason why this worked this way, and they don't have the tools to really describe it in a factual way. And so it gets garbled, and, you know, you end up with some really strange things. People are saying, oh yeah, well, you need to do, you know, whatever, stand on your head on, you know, the night of a full moon, because you know, that's what makes the metal demon work, you know. And it's like, yeah, okay, you know, if that works for you. But yeah, I mean, there is a lot of information out there, but it can be hard to access if you haven't been trained in it. But like I said, there are a couple of really good books that I would highly recommend. One called Introduction to Precious Metals by Mark Grimwade. He was a wonderful guy. I got to meet him and know him through one of the conferences that I used to attend. Unfortunately, he passed away this last year, but I did get a chance to see him last year in the summer. He came out to London when I was there speaking, and it was really wonderful to see him. But he wrote this book for the working craftsman. It's not written for a metallurgist, and it gives you all of the basic underlying information about metals that we work with: gold, platinum, silver. Talks about a very wide range of things from the basic materials themselves to casting to alloys to, now he even has a little bit about Mokume in there. So it's a great book. So I would highly recommend that if you're interested in it, that's a good place to start.
You have yourself written extensively about Mokume Gane, but also recently published a very interesting paper titled A New Method for Preparing 3D Printed Acrylic Photopolymers for Investment Casting. Could you tell us a little bit what you investigated there and how this happened to come across in your practice that this was necessary for investigation?
I've been attending a annual conference on jewelry making and technology for 20 odd years now, that's held in New Mexico. And unfortunately, the conference is no more. They're not going to do it again, but it's through that conference that I would go every year and listen to people presenting papers on a lot of different subjects. And I got to present several of the papers that I've written on Mokume. And, frankly, there are not that many people there at the conference who are interested in Mokume necessarily, but, they would politely listen to me and they'd tell me when I was not really correct in some of my assumptions. It was a great way to learn things because there were real, honest to God, precious metal metallurgists there, which is a pretty rare creature to come across. So I got interested in doing research for those papers. And then there are a couple of other areas that I had some interest in. And I got interested in the 3D printing because it really combined, the electronics and computers and stuff that I had worked in before. And I had seen back when I was working in research, some of the original first generations of 3D printers and had seen some products that were actually developed in CAD and then printed on a 3D printer, and you could actually hold it in your hand. And that was like, wow, this is pretty amazing. So they started to show up in a lot of different industries and of course made their way into the jewelry industry. And one of the biggest, there's several issues with them over the years and they keep getting better and better. So now things are a lot easier than they were a few years ago. But there were a couple of things that were a problem for jewelry. One was the resolution. If you've ever seen these parts, depending on what process they're used and which machine and the skill of the operator, you can have some pretty bad surfaces on the castings when you get them. They're like, God, why did I spend all this time and money to do this? I could sit down and carve this in 15 minutes and get a way better surface. But they are getting better. And they do allow you to do a lot of interesting things. So there's been a very strong interest in the industry and learning how to make them work and fixing the problems. So resolution gets better. But one of the persistent problems in casting these resins directly is that the resin is not wax. We know a hell of a lot about burning out wax and making it work. We've got 100 years or so of technology in casting wax patterns in investment molds. So what would happen is you'd get castings that have some places really good surfaces, and in some places it looked like somebody slapped a bunch of cottage cheese on the surface before they invested it, because you've got all of these really nasty defects that are mostly positive defects where, the defect extends out from the surface of the casting. So, we're used to seeing negative defects mostly of, porosity and bubbles and non-fills, things like that. We know how to work with that, but it's all of a sudden, here's this huge ugly growth on the side of your casting. And it's like, I know it didn't look like that when it went in the flask. So what in the hell happened? And it's surprisingly hard to analyze what's going on inside of a flask as it's going through the whole process of being vacuumed and the plaster sets, and then you put it in the furnace and burn it out. It's like, yeah, it's easy to look at from the outside, but what's actually happening inside of there? And so there've been a tremendous number of papers written on what's going on, what are our guesses, again, we were getting into a lot of stuff about, if you just do this thing and hold it this way and do that, all of these kind of magical thinking processes that somebody'd say, oh yeah, I'm getting great casting. And then somebody else would try the same stuff and go, what are you talking about? It's crap. So I got a printer and I started trying to do some of these things, and I was having the same problems that everybody else was having. And I started trying to go about looking at it. I will not call myself a scientist. I'm not a scientist, but I tried to start going at it in a methodical fashion to try and say, okay, so what's different between wax and the plastic? What do we think is going on here? What are some of the ideas? And eventually I came to believe what was going on was that the resin was not being fully cured in the printing process. There's a lot of research and literature written about the 3D printing process. And when you go through it, you can find, some of this information about reasons why they don't try and achieve a full cure as the resins are being printed. There's a lot of reasons why they don't do that. But the end result is you have a model that is semi-cured. So there's some hardened resin and there's some resin that's not fully cured in the model. When you put that uncured or semi-cured model through the investing process, there's some kind of reaction going on between the model and the investment. My theory was that when you put it in the flask and expose it to vacuum, that you're actually drawing some of the uncured resin out of the model, and it's accumulating near the surface of the part. And then as you go through the process of burning it out, the resin cures, and due to the various stresses that happen on the materials as they're heated up, it's actually pulling chunks out of the face of the mold as it heats up and as the plastic degrades and finally burns away. That, in a few words, is what I was looking at. I developed a process to fully cure the resin before it was invested, and the process works. I'm able to get really, really nice, clean surfaces on my castings. I started doing that research 6 years ago now. So the resins have gotten better. A lot of the things, people are getting better results now with, straight growth of the resin and some of the curing processes. But there's still people who have problems, and some of the modern resins still have problems. And I think it's still related to this not being fully cured. So my paper was, what do I think is going wrong, and how I proposed and showed one method to fix it. Certainly not the only method, but it is a method that works, and I think validates some of my assumptions about what was going on inside the flask. So I presented that the first time at this conference in New Mexico in 2016, and then was asked to present it again in London last year for the materials conference in at the Goldsmiths Hall. And then one of the fellows that I had met through the conference or in Albuquerque, New Mexico, who's a German but works with an Italian company, said, hey, how would you like to come to Italy and present at Vicenza? And so in January of this year, 2020, I went to Vicenza d'Oro and presented the paper again. And so it's been fun to take that paper around and talk to a lot of people in the business about it, and get some validation on my research. And I love looking at problems like this and trying to figure out what's going on and trying to solve them. I'm definitely that's a big part of my personality is oh, here's a problem, let me see if I can fix it.
You are often consulted for your knowledge of metalwork, and I would say for your problem-solving approach to metalwork and to techniques. Do you feel that metalworking skills are still sufficiently being passed on? And do you feel that there are certain techniques and skills under threat and that there should be other things that we should be focusing on more, like you are combining the scientific approach as well? Do you think that's something that should be included more in universities, or do you feel that something potentially naturally comes in practice? What's your thoughts on these ideas?
I think that a tremendous amount of what is done today in the jewelry industry is done in a way to produce something as rapidly as possible for the lowest cost possible. No matter whether you're talking about, a small time manufacturer or, one of the big luxury houses, for the most part, they're very interested in trying to have high production volume at low cost. So things like investment casting end up replacing fabrication. So instead of fabricating a model and then giving it to a variety of craftsmen to engrave and chase and repousse and do all of these things to create the form that you're looking for, somebody sits down and carves a wax, or they sit down at a computer and they design it in CAD, and then it gets printed. Then rubber molds are made and they cast a lot of them. So there's a tremendous amount of focus on lost wax casting. And lost wax casting is a wonderful technique. It allows you to do a lot of great things. But what happens is a lot of the other traditional metalworking techniques get bypassed or relegated to specialty hand shops. Engraving is a good example. Finding people who really know how to do high quality engraving is getting harder and harder and harder. There has been a resurgence at the craft level in some of that. In the trade itself, it's not nearly as widely practiced as it used to be. So I think it's important that these skills be preserved, because there's a wide range of types of jewelry. There's the mass-produced market, and then there's the high-end bespoke work that's done at levels where you can't afford to spend the time to use those techniques to produce stuff that frankly you just can't do in lost wax casting. If you look at a wonderful highly engraved piece and compare it to something that's generated either by hand or computer in wax or plastic and then cast, there's a huge difference in the surface quality and the way it feels and looks. For most customers that may not make a difference, but for some customers that's important. And I think for the people who do it, it's very important to be able to take their vision and execute it using their hands and the skills that they've developed to do these things. So I think it's important to preserve these skills, and it's a hard fight. Again, economics versus the artistic and creative aesthetics of how a piece looks when it's say hand engraved versus CNC milled or whatever.
Yeah. So you touched upon that you write and you put papers together and that you attend conferences to share your research and your findings. Do you feel that is become an important part of your practice? And do you feel that there should be more opportunities for the industry to connect like that?
For me personally, it's been very rewarding to go to these conferences. I've managed to meet people who I never would have been able to come across in day-to-day context of what I do, and access a really wide body of knowledge. This conference that I went to for so many years in New Mexico was called the Santa Fe Symposium for Jewelry Manufacturing and Technology, and it was in a large part put on by a jewelry supply company here in the United States called Rio Grande. And one of the principals of Rio Grande, by the name of Eddie Bell, was very interested in these kinds of problems and started this conference and felt very strongly that we needed to bring people together to talk about the issues that we have on a day-to-day basis in trying to make better work. And he managed to collect people from all over the world to come to this conference. Tremendous number of papers were written, contacts were made. People, they're people that I can, email or pick up the phone and call, that there'd be no way in the world I would ever be able to reach them, except for the fact that I attended a conference with them and I talked to them a little bit, and they at least know who I am if I was to try and reach out and talk to them about something. And, the people that attended this particular set of conferences ranged from individual goldsmiths working in their studio to people from Tiffany, Cartier, Bulgari, the big houses, Swatch, Rolex. I met people from all levels of the industry there. And I think it's very important to bring those people together, because what happened at that conference was people would get together and they'd be able to talk in a way that they were not able to talk in any other social context. And problems got solved that affected everybody, but you wouldn't be able to walk up to a competitor normally. Somebody working at Tiffany's wouldn't be able to walk over to somebody at Cartier and say, oh, we're having this problem with, whatever. And, how do you guys deal with that? Those conversations would never happen. Whereas, somebody sits down and writes a paper about something. Yeah. And the other thing about the conference, it was very non-commercial. It was not to be an advertising platform. You were talking about scientific and technical issues. So, when you take that level of commercial aspect out of it and say, okay, we're going to talk about scientific and technical issues here, and you present a paper on solidification of 18 karat gold castings, that was done by a findings manufacturer here in the United States called Stuller, and they instrumented flasks and they showed how fast the materials cooled in the flask, and there's a lot of good information there. So everybody's sitting there going, hey, yeah, that's pretty cool. And you sit there after the day's papers and you got a beer in your hand or a cocktail or whatever, and you're talking about, well, and we've had a similar problem, and this is kind of how we approached it. And this huge body of knowledge grew up out of that social interaction that was very important. And I think if you look at the time period involved and the gains in knowledge in specific about lost wax casting that conference created, it's pretty amazing at what happened. So I think it's very valuable to get people together in a context that's not driven by the market and not driven by, oh, well, who kind of thing, but you're just all there hanging out and talking about things at a kind of a more abstract level, but it allows you to solve a lot of interesting problems. So greatly valuable. I think I would encourage more of that kind of thing going on. I think, that there are other conferences, they're, more focused on different areas. Like there's more academic art conferences and things like that in the United States, where, it's a different focus. I think they're all good, but I really do think that it's a good thing for people, from different parts of the community to get together and talk about these things and figure out how to solve problems. Because, frankly, we all have the same problems in these, if we're all trying to do the same kind of work, we're going to be running into the same problems. And like as not, somebody may have figured out a way to get around the problem that you're having, but you're not going to know about it unless you all get together and talk about it.
And sometimes just approaching things with different perspectives and having those conversations can really stimulate new solutions.
I think it's incredibly important. Yeah, it really is something we need that everybody at all levels of the industry and craft need to support, and either attend or financial support, whatever it takes. But I think it's tremendously valuable and needs to continue on some level.
What is at the moment inspiring you? Can we expect any new research outcomes, or is there a problem that you're thinking of solving in the near future?
Not really problems. I've been doing a lot of work with trying to figure out some new patterning methodologies in Mokume. Been doing a lot of work with relaminating. So laminate it, pattern it, and then laminate it again and do some other things to try and generate more, different patterns. And I am working on something right now that I hope the equipment that I use, the electric kilns and a lot of the equipment that I use on a regular basis in making Mokume it's expensive. I've spent a long time putting a lot of this stuff together. It's kind of intimidating for a lot of people, especially small studio craftspeople, to try and do this process the way I've been doing it. I've taught a lot of people how to do it, and I think they run into issues with trying to have the equipment available to them. Sure, if you're in school, you may have the presses and the kilns and all of this stuff available in school, but then you get out in your own workshop and it's like, how in the world am I going to do this without spending many thousands of dollars, thousands of pounds to buy all this equipment? And how do I do that? That's hard. So I noticed that there's a large number of people who are doing lamination, especially in Europe, using torches to do the fusing of the Mokume, and with varying levels of results. There's some people who are quite good at it, but it's really hard to do it with a torch and not overheat it. I don't want to get too off in the weeds technically here, but I've been working on a small tabletop system to allow for a less expensive means of approaching the kind of thing that I'm doing with my electric kilns and so forth. So it's kind of a hybrid technique. And I'm hoping fairly soon to start having some maybe some videos or whatever showing how this is done. And maybe I haven't quite decided whether I'm going to just put together a set of plans and you can, purchase the plans, or if I'm not too crazy about trying to go into the equipment manufacturing business, but a way to try and get into it for a lower cost and yet achieve superior results. Because unfortunately, I do look at a lot of the Mokume that's being made, and it is, frankly, it's overheated. They've gone too far, and I understand why. It's very easy to do with a torch, and so I'm trying to figure out if there's not a way that we can't control that a little more easily, on the tabletop level, metal smithing.
I think that's really interesting. More so than ever, it's important we continue to investigate, innovate, and dedicate time to the techniques that bring us insight into metalwork beyond its superficial properties. Furthermore, a technique like Mokume Gane and other techniques require a certain attitude, patience, and a stillness, which can also teach us something about life and the acquiring of hands-on knowledge. For these and many other reasons, masters like Jim share and discuss their work, and their knowledge is incredibly precious for all of us interested in making today. Therefore, I would like to say thank you so much to Jim Binnion, who joined me for this very inspiring discussion. Thank you, Jim.
And thank you very much for inviting me. I enjoyed it.
Superb. Next month, I'll be joined by another guest, so watch this space to find out who it is. For now, this was Sophie Boons for the BAJ Podcast series, Mokume Gane and Modern Craftsmanship with Jim Binnion. Thank you for listening and have a wonderful day.